Hello, welcome to today's mathematics tutorial. Today we're going to look at sum of terms of a geometric progression. The sum of terms of a geometric progression is obtained by adding the individual terms of a given exponential sequence. Example, giving t1 a t2 equal to ar. How do we get a sum of this exponential sequence? We have it as the sum will be equal to the first term plus the second term. We call this equation 1. Now, from here, what are you going to do? You multiply both side, by r. Multiply both sides by r. Multiply the left hand side and right hand side by r, and that will give you r times Sn is equal to a times r. Just use the first term here. So definitely we have r times Sn will give us Rsn is equal to a times r will give us ar raised to power n. Because we're dealing with the number of terms here. So we call this equation 2. So what are you going to do here? From here we said you subtract equation 1 from equation 2. Now let's subtract equation 1 from equation 2. That will give us Rsn minus Sn is equal to a Rn then minus a. From here, what do we have? We have a common factor which is Sn. We collect the common factor Sn in bracket. Sn cancel Sn remaining r minus Sn cancel Sn will give us 1 equal to the common factor here is a. A cancel a remaining r raised to power n minus a cancel a will give us 1. So make Sn the subject of the formula because that is what you are trying to find. Making Sn the subject of the formula means you divide both sides by r minus 1, and here will be by r minus 1. So this cancel this, we have it as Sn, the sum of terms of the geometric progression will be equal to a raised to power n then minus 1 all over r minus 1. And this particular formula is used whenever the r is greater than 1. Whenever r is greater than 1, that is r is positive, you make use of this particular formula. Now let's take down, what if you subtract the higher equation from the smaller one? What will the result look like? Let's go down to subtract. We have subtract equation 2 from equation 1. That is subtracting the higher equation from the smaller equation. That will give us Sn minus Rsn equal to, we have a minus ar raised to power n. The common factor here still remains Sn. Then in bracket, Sn cancel Sn will give us 1 minus. Then we have that is common factor Sn in bracket. Sn cancel Sn will give us 1 minus. Sn cancel Sn here remains r equal to the common factor here is a. A cancel a will give us 1 minus. A cancel a remaining r raised to power n. So make Xn the subject of the formula as usual. You divide both sides by 1 minus r, and here will be by 1 minus r. So this cancel this, we have it as Sn is equal to a in bracket 1 minus r raised to power n all over 1 minus r as the denominator. Therefore, when do we apply this particular formula? This particular formula is applied when r is less than 1. That is when the common ratio is less than 1. So let's just go down with this particular example. Example 1, which says find the sum of the first three terms of a GP. Find the sum of the first three terms of a GP whose first term and common ratio are 2 and 3. Whose first term and common ratio are 2 and 3 respectively. So how do you get this particular sequence? Let's just go down with what we have here. We have from this particular place, we go down with the first one. Just bring out the parameter. Find the sum of the first three terms. You're looking for the sum of the first three terms, which is unknown, of a GP whose first term and the common ratio are 2. The first term is 2 and the common ratio is 3. Therefore, the common ratio is greater than 1, which means we make use of the first formula. And the first formula says that Sn is equal to a in bracket r raised to power n minus 1 all over r minus 1. Therefore, we are looking for the sum of the third term. The S3 will be equal to, so a first term here is 2 in bracket, r is 3 raised to power 3 minus 1 all over r here is 3 minus 1. So we have it as sum of the third term is equal to 2 in bracket. 3 raised to power 3 will give us 27. It's 27 minus 1 then divided by 3 minus 1 here will give you 2. 2 cancel 2. What do we have? 27 minus 1 will give us 26. So the sum of the first third term of the geometric progression is equal to 26. Now what if a question that involves different terms, but the first term and the common ratio is not given? How do you get this particular question? How do you solve this question? Let's go down to example 2. Example 2 says if the sum of the first two terms of a GP is, if the sum of the first two terms of a GP is 12, and the third term is 27. If the sum of the first two terms of a GP is 12 and the third term is 27, the question says find the fourth term of the GP. Find the fourth term of the GP. If the sum of the first two terms of a GP is 12 and the third term is 27, find the third term of the geometric progression. How do you solve this? It's just very simple. What you have to do is you bring out the parameters you have in the question, first one after the other. Bring out the parameters we have there. If the sum of the first two terms of a GP is 12, first two terms means T1 plus T2, if the sum is equal to 12. Then how do you get it? Your T1 here is A, plus T2 is obtained as AR, highest power is 1 less than this, which is 1. So you have it as AR equal to 12. So we have common factors here. You collect the common factor. The common factor here is A. A cancel A will give us 1, plus A cancel this will give us R is equal to 12. We call this equation 1. Then we continue with the sentence. And the third term is 27. The third term of the GP, T3, is equal to AR. The highest power of R will be 1 less of 3, which is 2, is equal to 27. We call this equation 2. So equation 2 is resulted on equation 1. As a result of that, you have to divide. We divide equation 2 by equation 1. And that will give us AR square is equal to 27 in equation 2 divided by equation 1, which is A in bracket 1 plus R, then bracket close, divided by, here is 12. A cancel A is gone, and what can divide here? We have 3 by this will give us 4, and 3 by this will give us what? 3 by this will give us 4, and 3 by this will give us 9. So definitely you now bring out what you have here. That will be equal to, we have R square is equal to 9. Using that of the numerator. If you like, you can use the denominator or the numerator, you get your answer. It's still the same thing. So here we are using the numerator. We have R square is equal to 9. Make R the subject of the formula. You find the square root of both sides, and that will give us R square raised to power half is equal to square root of 9. This cancel this. R is equal to square root of 9 here is what? It's 3. So we have obtained the common ratio. And how do we get the first term before we can now find the fourth term of the geometric progression? From here, you now choose any of the equation. Using any of the equation, we go down with the equation 2. Using equation 2, you substitute for R equal to 3. What does it mean? Anywhere you see R in equation 2, you call it 3. So here we go down with what we have. Substitute for R equal to 3, and that will give us equation 2 as AR square is equal to 27. A is unknown times R here is 3. 3 raised to power 2 is equal to 27. So we have it as A is 27. Have it as A times 3 raised to power 2 here will give us 9 is equal to 27. A times 9 is 9A equal to 27. Then make A the subject. You divide both sides by 9. 9 cancel 9 is A equal to 9 by this here will give us 3. So the first term is 3 and the common ratio is 3. Then the question says find the fourth term of the GP. Now you can find the fourth term of the GP. Why? Because you now know your first term and you know your common ratio. So let's go down to the fourth term of the geometric progression. The fourth term, which is T4, will be equal to what we have there as AR raised to power. The highest power here will be 3. That is 1 less of the number of terms we are solving for. And that will be equal to, our A is 3 times R, common ratio is 3 raised to power 3. So we have it as T4 equal to 3 times 3 raised to power 3 here will give us 27. And 3 times 27 here is equal to 81. So the fourth term of the geometric progression is 81. So that's just have to find the sum of the geometric sum of the terms of a geometric progression. It's very simple. For more of my video, don't forget to click on the subscribe button and the bell. Leave your comment. If you have any other question pertaining the sum of terms of a GP, send it via my email address, which is on the screen. Thank you, and see you some other days. Bye.